Guys, welcome back to second semester. In this semester, we are going to do our SK025 chemistry, and this is our very first chapter, chapter 1, reactions kinetic. So for chapter 1.1, we are going to look into reactions rate. So here is the learning outcome. You may refer to your notes given. So first of all, reactions rate. This reactions rate refers to the change in concentrations of reactant or product per unit time. So this unit of time can be in second, in minute, in hour, in days, weeks, year, century, and etc. Depends what is given in the questions. So the reactions rate has the units of concentrations per unit times, which it can be molar per second, mole per dm cube per minute, mole per liter per hour, and etc. So referring to this graph of concentrations of reactants and products, so A being the reactant and B being the product. Here over here, initially you have the concentrations of reactant, and then it decreases over time. Well, initially there is no product, but this concentrations of product will increase with time. Okay, so based on the graph, concentration A decreases while concentrations B increases with time. So given the formula over here, you have rate equal to the change in concentration A or change in concentrations B over the time taken. But since we know that the reactant decreases with time and product increases with time, therefore we need to differentiate between both reactant and product using differential rate equation. So this differential rate equation shows the relationship between rate of disappearance or rate of depletion of the reactant and the rate of formations of product. So using a general formula over here, A, B, the reactant, producing C, D, the product. So the small letter A, B, C, D are their stoichiometric coefficient. So to do our differential rate equation, you can do it as shown over here. So starting with the words rate equal to, remember that reactant will decrease with time, so it will disappear or deplete. Okay, so we are using a negative sign to represent reactant that is being used up in the reactions. So negative 1 over A. So this stoichiometry in the balance equation will become the denominator. Okay, and then we have D concentrations A over dt. Okay, similar for our reactant B, negative sign represent the rate of disappearance. So 1 over B. So coefficients in the balance equations become the denominator. So D in the square bracket B over dt. So we are using a positive sign here. Okay, again, 1 over C. Coefficients become denominator. So dC over dt. And then lastly, we have plus 1 over D. The coefficient become denominator, dd over dt. So remember that negative sign indicate that the concentrations of reactant decreases and positive sign indicate the concentrations of product increases. So that is in general. So let's try an example over here. So you can see in this balance equation, we have CH4 plus 2O2 to produce CO2 and 2H2O. So in this case, all the phases are in gas and we can use as the concentration. Okay, so starting with the words rate, and then the reactant CH4 coefficients 1. Therefore, 1 over 1 equals to 1. You don't have to put inside your differential rate equation. So it becomes negative dC4 over dt equals to, for O2, there is a coefficient 2. Okay, so these coefficients become the denominator. It becomes negative 1 over 2 CO2 and H2O are their products. So we are using a positive sign. So plus d CO2 over dt since the coefficient is 1. And then lastly, the product H2O, we have the positive sign to represent product. So plus 1 over 2. Alright, so for questions number 1, write the differential rate equation for the reactions below. So first of all, you need to check whether this equation is balanced or not. Secondly, you need to check, okay, is all the phases can use the concentrations. So remember that concentration, we can only use either you have a gas phase or an aqueous phase. Okay, so differential rate equation will start with the words rate. Remember, this is very important. Okay, start with rate and then equals to the reactant first. So the first reactant, we have a coefficient 2 over here, so -1/2. And then we have the D, in square bracket, you have your reactant ClF3 over dt. So the second reactants over here, still we have the coefficients too, so still -1/2, and then dNH3 over dt. And then after that, we have our product, which is N2 with coefficients 1. So it will just be a positive dN2 over dt. And then our second products over here with a coefficient 6. So in this case, we have a plus 1/6 dHF over dt. And lastly, for the product Cl2, still we have our coefficients 1, so plus d square bracket Cl2 over dt. So very straightforward, the differential rate equations. So if you want to do for every species, here is the answer. So for our questions number 2, hydrogen sulfide burns in oxygen to form sulfur dioxide and water. So you're given a balanced equation and all the phases are in gaseous state. So given that if sulfur dioxide SO2 is being formed at a rate 0.30 mole per liter per second, what are the rates of disappearance of hydrogen sulfide? So first of all, we need to come up with the differentiate rate equation. So here's your differentiate rate equation. But in the questions, you are given the formations rate or the rate of formations for sulfur dioxide. Okay, so we may write over here the rate of formations represented by a positive sign, rate of formations of sulfur dioxide. So the one that matters right over here is the rate of formation without any coefficients or denominator. So the rate of formations equals to the values given over here per mole per liter per second. Okay, so this is the informations given, and you may write over here or you may circle over here in your differential rate equation. Here is your sulfur dioxide. Okay, and our target is the rate of disappearance of hydrogen sulfide. So these two, madam, square root is the informations or the target that we want to find. So we try to put them together. So -1/2 d concentrations of hydrogen sulfide dt equals to positive 1/2 dSO2 over dt. Okay, so now we want to find the rate of disappearance without any denominator or the coefficients. So try to rearrange it. We bring over this 2 over the other side. So now it becomes negative dH2S over dt. So this 2 bring over to the top over here. So we have 2 times 1/2. And then this plus dSO2 over dt, we have a value 0.30. So 0.30, you substitute in the bracket here. Alright, so referring to the informations over here, since the rate of formations, we have a positive sign ds2o over dt equals to 0.30. Therefore, in your equations over here, the positive sign together with dsO2 dt are equals to 0.30. Therefore, the rate of disappearance of hydrogen sulfide H2S equals to 0.30 mole per liter per second. And since the ratios are the same, if you look at the balance equation, now hydrogen sulfide and SO2, they are the same. So the rate or the are equals also. But this one is to show how how are you going to solve the problems like this. So lastly, we need to write a sentence to refer back to the questions, yeah? So the rate of disappearance is 0.30 mole per liter per second. So given the balance equations on the top, based on the reactions above, nitrogen gas is produced. So this is rate of formation at the rate 0.056 molar per minute. So the unit for the time is minute. So we write out the information over here. So reactant, positive sign. Nitrogen gas, you have a formula N2 over dt, which is equals to 0.056 molar per minute. So we have to calculate the rate of formations of HS. For formation, you have a positive sign, so dHF over dt. Write out the symbol first. Okay, remember that the rate of formation, it doesn't have any denominator or the coefficient. Okay, and then the rate of depletion, so depletion refer to reactant, negative sign, we have dClF3 over dt. So again, from the information, to solve for the first one, rate of formations of HF. So from your balance equation, HF has coefficient 6. Okay, therefore we have to write out the formula first, including the coefficients. So that is your differential rate equation, all right? So product plus 1 over 6 dHF over dt equals to the informations that we have is nitrogen gas. Okay, so nitrogen gas coefficient is 1. Therefore, it's equals to 1 over 1. Okay, so N2 over dt. So in this case, remember that we want only the positive sign dHF over dt. So we have to eliminate the denominator 6. Okay, so bring over onto the top. So 6 times with the rate of formations of N2, which given here, the value. So 6 times 0.056 molar per minute. So the rate of formations of HS equals to 0.336 molar per minute. Alright, to write in sentence, it will be rate of formations of HS is 0.336 molar per minute. Okay, so go to the second one, rate of depletion. So according to your balance equation, ClF3, you have a coefficient 2. Okay, and then the information that we have got is the nitrogen gas. So write out the formula first. So the one that we want to find, we put as the subject. So reactant, you have a negative sign, 1 over 2 dClF3 over dt equals to the information for nitrogen gas. Okay, so to eliminate until we got this formula. So negative dClF3 over dt, eliminate the denominator 2, so it becomes 2 times the rate of formations of nitrogen gas, so 0.056, and the answer equals to 0.112 molar per minute.